Thank you very much for the introduction. Good afternoon. So I have a bit not a good position because I have, I think, minus 10 minutes. So I will try to be as short as possible. So my presentation, so I would like to talk about a very simple approach, how to identify the energy reduction opportunities in the food SMEs. These results came from a European Cornet project called IMS Food. Nowadays, fewer and fewer solutions available for the food SMEs for maintaining the long-term competitiveness. It's important because the quality and reliability shall not be compromised, but lower prices shall be achieved by elimination or reduction losses and wastes of time, different issues, time, material, human and other resources like, thank you, like energy and water and improvement of efficiency. What we can do if we don't want to deteriorate the quality of the food, if we want to comply with the obligatory regulations, and if we don't want to discourage the employees. So there are many different technical innovation facilities. We can heard about it in some excellent presentation during the conference. But the other side, the other facility, how to change the management thinking, how to create a new management methods to reduce the costs in an easy way. There are several novel methods in the manufacturing sector, so-called lean techniques. These methods were developed mostly for mass production in the car manufacturing, IT hardware industries, and so on and so on. So what is typical in this industry, the high capacity, the automated production lines, large volumes, relatively uniform quality. So it's not typical in the food industry and mainly not typical in the food SMEs. So the original idea was how to adapt to these techniques to the food industry. A typical output was that the managers of the food SMEs are mostly not familiar with different acronyms like the different lean techniques, 5S, 6 Sigma, and so on and so on. They don't know what is it. They don't know which one do they need. What are the differences between the techniques, and what does it really mean when we say, for example, 5S. So that was the cause why we planned to create a toolbox, the applicable techniques, a framework how to use these techniques, and of course the main goal was reduce the costs, so we had some pilot projects. A quick overview about the project. So we identified the industrial needs and collect the available techniques and systemize this system. We developed an inventory which was consulted with the industry in different workshops in different countries, and after it we had some pilot, as I mentioned before. The approach, the original idea was very easy. So it's a structured approach based on the hazard analysis system. But despite of the hazard, we analyze the facilities, how to identify the possible savings, the different wastes or non-effective operation. So let me show you some quick success story. First, an old traditional medium-sized bakery where originally we planned to find the material wastes. So the floor wastes was the huge issue at this company. So all the identified problem came from the technological problems. This figure shows you what is really interesting, the two bottom line, the dark blue and the green one. The adjusted weight, the bottom is the adjusted weight of the so the lower one, sorry. So the lower dark blue is the adjusted weight of ban roll, so small, like the panini, I think. It was adjusted between 52 and 56 grams because it's a Hungarian law that this product weight have to be between these two limit. And after the calculation and data collection period, we saw that the calculated weight was 10–15% higher than the adjusted one. So it was really interesting things, but the mathematical model says that if we divided the weight of the raw materials and the number of the final product pieces, it was sure. So the calculated DAF weight is a simple result on this formula. So when we analyzed this problem, so the really problem was that a small part of the adjustment was misaligned. So the feeder was bad condition, and the employees didn't check the final products just before the shift and after the shift. So it was a 5 hours where it was a very changeable parameter. So when we calculated this after a 3 months period, it was 15,000 euros from the material wastes. So it's overproduction. It was sold free for the customer. But parallelly, it was an energy wastage because they use energy for a free product. So it was another 8,000 euros. So this 23,000 euros is not the same number what we saw in the previous presentation, but if you think that a small bakery in Hungary, so this 23,000 euros is almost 1 month for the salary for all the employees. So it's a big issue, can be a big issue, and the solution is very easy. It was a 60 euros particle, the new fixture for the feeder, and some extra training for the employees. Another issue was the thermal-based vision analysis. There was an extremely bad condition. This oven is 50 years old, but the company had no money to change it. So it's extremely bad condition. So we have numbers, but I think I have no time to go through. And another one is the exhaust pipes. They don't use the heat energy of the exhaust gas and it go through the outside. It was another payback calculation, but it was interesting that this we calculate for 5 years, and the available investment was only 6,000 euros, so the technology solution is given, but the return on investment was too slow, so we have to thinking further this problem. And the last case study was the quick frozen corn kernel production line, where the main goal was how to save the electricity and gas consumption. After the calculation, so you show only, so real number is confidential, so it was not give us, but you can see that if so I'm going back to so the findings was the line capacity, it's 4 tons per hour. I am ready. So the line capacity is very important, this production. So the more often stop the production, the higher will be the losses. So it's the problem in this company that if the lack of the raw material or any technical problem, they have to stop the line. It's a big issue, because if the line is operating 4 hours, for example, it's 1.5 more power energy and 1.8 times more gas consumption than the normal way. And very short, some problems. You can show that without real information, so our main experience was that without real information, there is no decision from the management, and the different motivation level of the staff, so is very difficult. And the key employees are very busy, who has to had to do the data collection to make decision. So that was my short presentation. Thank you for your attention.